Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, let's get started. Thanks everyone for coming out. My name is Ben Lauer, and I'm working with a couple of colleagues here at MSR to bring ZapFest to you this summer. And this is our fifth session out of our initial 5 that we had scheduled to give everyone an overview of Windows Phone development and really help everyone get up to speed. And we will have some more sessions next month. The next session that we have will be Wednesday, July 13th, and that's going to be, we're actually really privileged to have a senior dev lead from the Silverlight team, Jeff Wilcox, is going to come. It'll be very casual, so this is a kind of like an Ask the Expert session. So if you're having performance issues or questions about Silverlight, bring your laptop, bring your project, and Jeff will be on hand to help you work through any issues that you're having in Silverlight. I'd also like to have feedback from everyone, possibly at the end of the evening, if there are other topics or experts that you'd like us to bring in so that we can get you the help or information that you're looking for. Also, if you're participating in the intern contest, just a reminder that Tuesday, so that's this coming Tuesday, which is July 5th, is the deadline to submit your project idea. And you can change it. It's not like it's locked in stone, but we need to have an idea of how many people are going to be participating. Was there anything else, G2, that I was supposed to mention? Okay, yeah. So I think Nick's going to talk more about how you can get a free trial account with Azure. But G2 wanted me to let everyone know that if you are really looking to go into Azure and really use it a lot for your project, that you can email us at HiZapCrew alias, and we have some additional access options for people in the contest. So with that, it's my pleasure to introduce Nick Harris, who's a technical evangelist in DPE, specializing currently in Windows Azure. And I really appreciate you coming out, Nick, because I know this was a little bit... Our original speaker was out on paternity leave, as it turned out, Wade. And so Wade was able to get Nick to step in kind of at the last minute. And Nick's also a little under the weather, so really appreciate you coming and helping us out. So here's Nick.
Okay. Good day, guys. So I'm Nick. I think, as you mentioned, I'm a little under the weather.
Are you mic'd up?
Yeah, I'm mic'd up. So a little under the weather, so I'll probably just sit a lot this session rather than stand and walk around, if that's okay. It's pretty hands-on anyhow, so we've got a few demos to do. So I'll just sit here. So the session is how to rock harder using Windows Azure. It's a level 200 session, so we're not going to go very in-depth in code, but you're going to see a lot of demos and a lot of concepts within the deck. So without any further ado, let's just sort of jump right in. So I'm Nick Harris. I come from a background that's quite diverse. So I started out my development career writing software for helicopters. I then moved from there into building mobile applications that are utilized currently today nationally around Australia. Following that, I did a lot of work with distributed enterprise systems. And more recently, I started my own startup, and that's a Windows Azure-based application that delivers advertisements in-app to WinPhone 7 applications. And now, in my role as a technical evangelist for Windows Azure, in my day-to-day job, I build resources for developers. I build demos and present at conferences. Excuse me. And I also work with customers and partners to help them adopt Windows Azure. So what about you guys? Well, in putting this deck together, I needed to make some assumptions about who may be here. I had a bit of an idea from Ben. So the majority of you will be developers. So could you raise your hand if you're a developer? All right, so that's good. That's about 90% of the people, or 95, with the exception of 2 guys, 1 guy on a laptop. How many of you are staff? So we got, how many staff members do we have here? All right, so a few staff, maybe 5, and I assume the rest are interns, perhaps? Okay, cool. So how many of you have utilized Windows Azure today? So we've got about 4 people. And how many are actually building Windows Phone 7 applications? All right, so that's most of you. So this session is going to be really good. So the content here is going to give you a great understanding of Windows Azure, but we're also going to look at how you can leverage that from Win Phone 7. So getting started. How do you jump in and get started with Windows Azure development? So I assume these slides will be made available on the HiZap portal. Yep. Now, what I've got here is a bit.ly link to the all-in-one installer. What this does is this will go off and install the tools for Visual Studio and the Windows Azure SDK. So quite simple, quite straightforward. Click on here, and after that, you're ready to go. So I'm just showing you these things because these are things that I've already installed on my desktop here. So the Windows Azure Platform Training Kit. Now, that's one I recommend you go out and install. It's a toolkit full of labs, presentations, and demos. So if I were to click here, this is the installed content. I'm just going to pull it across on the screen so you can see it. What you've got is you've got a whole list of demos doing everything from getting started, utilizing storage, utilizing SQL, utilizing the App Fabric, Service Bus, ACS, and whatnot. The real benefit of this is you can run this setup lab, and that will go and run a dependency checker that determines, do you have all the prereqs required for this lab installed? So that's a really great resource for you guys to utilize. And the last one is Cloud Cover. So this is a bit of a informative but wacky show that you can watch. And the hosts are Wade Wagner and Steve Mark. So as you can see here already, just based on what they've got a really great editor called Bob, and he sort of mixes in some really funny stuff. So as you can tell just from those couple most recent ones. All right, so they're what I'd say the sort of essentials to getting started with Windows Azure development. Now, apart from those, you need access to the Windows Azure. So currently, as Ben mentioned prior, that there's something available for you guys participating in HiZap. And I guess anyone else externally that may be watching this, we've got a 30-day free pass available here. I've got a to-do on here because I didn't have a code. I was going to give one specific for interns, but I'm still working on that. But given that Ben has said all you need to do is email those guys, that will suffice there. Otherwise, if you're external and you watch Cloud Cover Show, you should be able to go on the site there and grab a promo code for that. There's also, so the one on the left, the Windows Azure Pass, doesn't require a credit card. The one on the right does require a credit card, but that's only for any excess usage if you exceed the predetermined amount, and that lasts a lot longer. Okay. So, moving on. Let's jump straight into development. Okay. So I'm just going to exit this. Okay, and I'll bring my toolbar over here so you can see what I'm doing. So one of the things that gets most people out first when you build your first Windows Azure project is this. You need to run Visual Studio as administrator. Now, that's required for the compute and storage emulators. So what I'm going to do is I'm just going to come in and I'm going to create your first ever Windows Azure app. So there's File, New Project. Oh, the screen's a bit finicky. I'm going to select a Windows Azure project. So when you install the SDK, which I just showed you before, you get this cloud-based project. Hit OK. We'll talk about the Win Phone 7 ones in shortly, or towards the end of the session. Now, this allows you to choose 2 of the fundamental compute concepts, one being a web role and one being a worker role. So I'm just going to drop one of each of those in there. We've got support for C#, VB, and F# in there. And I'm just going to hit OK. Right, so what it's doing now is it's just building up the solution for me. So anyone here that's developed a website before will be familiar with what you've got here. It's your standard web project. It's got your same ASPX. You could have created an MVC website if you wanted. Now, that's common. we've also got, oh, I selected the wrong one there, sorry guys. I wanted to select a worker role. So you can see how to add another role here. Just going to add a new sorry. How was that? Right, no. Where am I? Wrong one, cloud project. New worker role project, that's what we wanted. Just going to drop this guy out. Right, so we've got our web role. Now we've also got a worker role. So anyone that's done any development for Windows services before, a worker role is similar. It's almost identical in concept. So a worker role allows you to go and perform long-running tasks or tasks in the background asynchronously. If you look at the programming model here up on the screen, the actual method that you're programming against, you've got an on-start, which fires up, you can perform initialization, a run, which runs forever, same as a Windows service, and you've also got an on-stop to do any cleanup as the role is recyclable or shut down. So that's a worker role. Now, both of these you'll notice have something inheriting from what's called role entry point. In the web role, we've got it here, and in the worker role, we've got it here as well. And that allows you to hook in to the I guess, this initialization or startup that the Fabric controller performs when you start an app.
Sorry, do you have questions
Yep.
during or afterwards?
We've got quite a bit of content, so maybe if we go to the end, if that's okay. Yeah. Okay, cool. All right, so those two projects are the same. You've seen them before. Now, this particular one here is what's new. So this is a cloud project, and this is what defines what we're deploying to Windows Azure. So you can see that we've actually got a reference in corresponding to our web and worker roles. We've also got a few configuration files here. So let's just have a quick look at this. So let's jump into the web role, just double-clicking there. You can see here, one of the core or fundamental concepts around your roles is that you can scale them. So a role can contain many instances. So this means it will go off and spin up another instance in Windows Azure for this. So if I wanted my web role to perhaps, say, have 2 instances, it's just a matter of making a simple configuration change. It's not very complicated to go and scale out your application so long as you've designed it correctly. You can also scale up. So you've got extra small, small, medium, and large based VM sizes. The extra small is 1 core shared. The small is 1 core dedicated. Medium, 2 cores. Large, 4, and extra large, 8. So you also have things like settings, so you can come here and start externalizing config settings, connection strings, and whatnot. If we jump into the worker role, you can also see just the same. It can scale independently as well. So I'm just going to leave that as 3, and I'm going to set it as extra small. Now, all of these changes are being made directly into our config file. So all UI-based configuration there for the majority of the features. It's all coming and dropping it in here. So you can see in our service definition, we're defining what Windows Azure is going to consume and to be able to determine what it needs to spin up. And in this case, we know that, okay, we've got a web role, it's got some endpoints on there, we've got a worker role. Over here on our service configuration, since this is something that changes and can potentially change at runtime, you can go into the portal and increase your instances or decrease your instances. We externalize that information into the service configuration. So you can see that we've got those instance counts here, and that's that. So what I'm going to do now is I'm just going to F5 and spin this up. So right now it's actually kicking over, building and deploying to local emulators on my machine. It's not going up to the cloud. You can do all your development locally, dev, test, and then when you're ready, you can go off and publish it up to Windows Azure. Right. Okay. So you can see there's our website. Quite straightforward. Now, recall we've got a worker role. We said we want to have a couple worker roles running there. I think I said 3. If I click down here, you can see over the Windows Azure logo, if you right-click on it, here are your emulators. So just like you have emulators for Windows Phone, you've got emulators for Windows Azure. So we've got 2, one for compute and one for storage. So I'm just going to drag this over into the screen so you can see. Right, so here's my compute emulator. You can see I've got a couple of web roles, instance 0 and 1, so we've got 2 instances, and 3 worker roles running there. If we click in here, you can see stuff being output. There's the role entry point with the on start and run. And over here, you can see we've got a worker role going and performing work. We've got 3 instances of that. So that's the compute emulator. Now we've also got a storage emulator. So what this does is this emulates the endpoints that we'd utilize for dealing with blob, queue, and table storage. Now, we'll get into these concepts shortly. I just wanted to, I guess, give you a lap around Visual Studio here. So that's the simple Hello World project running in the emulators. Now let's switch pace a little bit here, and what I'm going to do is I'm going to open a project that comes in the Platform Training Kit. So this is a lab in the Windows Azure Platform Training Kit. It's called Guestbook. We're just going to spin this up. So what I'm doing here is I'm just going to show you an application that's written to utilize web and worker roles, and it's just to set the context such that you understand the rest of the discussion. It'll make things make a bit more sense when we get into the deck. So quite similar, web role, worker role. These perform things, and we'll look at that. We'll just spin it up, and we've just got a library there that's referenced by those. So I'm just hitting F5 again, and we're going to run this guy. Right, so this is web-based. We will get to Winphone 7 in the second half of the deck. All right, so quite simple looking, right? So simple guestbook. I'm Cloud Nick, it's my Twitter alias, and we'll say maybe G'day Cloud rather than Hello World. And we'll use my alter ego superhero, and we'll upload this guy. So, right, I've uploaded a really large picture. So what's happened now? I've grabbed a picture, I've put a little bit of metadata against that, and now I've gone and said, okay, submit that. This is all running in my dev compute and storage emulators. And now I'm not touching anything here. What's happened is we've had a script manager with a timer fire and go and refresh the information on the screen. Now, question, how did we get our thumbnail? So we'll jump back to the deck and we'll look at that. Before I do that, if I click on this guy, you can see that over here, you've got this local host, and this maps back to that storage emulator. So I'm serving right out of storage that image, and it's a blob. Right. So let's close this down. Now back to the deck. Right, so we've seen demo of the development environment, a lap around. We increased the number of instances on the particular roles. We showed changing the VM size, we spun it up, and we also showed a running application, which was the guestbook. Now, what actually happened here? So, we already are familiar now with the concept of a web role and a worker role. What actually happens is when I grabbed that information being Cloud Nick and the message, I had to submit that. Now, I've submitted that through, and it's gone and pushed in to a web role. Now, how did we get the thumbnail? Well, what we've got here is we've got a message-based pattern, whereby we've got, we want to return, I guess, control to the user as soon as possible, so we offload the work to be done asynchronously. So my web role, when it receives this, we go and say, okay, let's go and store that image in blob storage, and let's go and store the message up in table storage. Now, you'll notice that BL1, I just had to shorten it so it fit in there, but that's a link to the blob link 1, so it's just a link to identify where that blob is in blob storage. Now, how do we get the thumbnail? Well, our web role also said, let's enqueue some work. So we've got our table storage, and then we've enqueued work in a queue here, which essentially says, create me a thumbnail. My worker role here is over, and it's running sort of and waking up every 10 seconds, I think, and going and checking the queue to see if there's work to be done. It pulls in the work. That says, okay, well, retrieve that image, create a thumbnail, store it back to storage, and now I've got a link to the thumbnail in Blob Store. I'm just going to update the table store here. Now, when that script manager and timer fired on the client, it just went and retrieved this record and pointed at the thumbnail, and then when we click through, it knows where the large image is as well. So whilst this demonstration is simple, it covers a lot of the core concepts. So as we proceed through the deck, I'll just sort of give you more detail about these concepts, the web worker and storage. How are we going? Good? Cool. Right. But what I'd like to show you now is quickly how you go and deploy an application to Windows Azure. So we've seen it running locally. How do you go and push it up into the cloud? So what we need to do is go to windowsazure.com. You can sign in. Right, so we understand the concept of compute, we understand the concept of storage. How do you create them? This is the Windows Azure portal. There's a lot of stuff here, but today we're probably only going to look at hosted services, perhaps DB, and the storage account. So we'll jump in here first. So I'm just going to jump in, go across, hit storage account. Now I'm going to go and create a new storage account. Now, storage account is publicly addressable, so it needs a subdomain here. So let's say Nick1. So it goes out, checks, make sure it's not taken already. Now, what I'm going to do is when I create this storage account, I'm going to create what's called an affinity group. And this allows us to co-locate our hosted services for our web or worker roles with our data, such that there's minimal latency when they're communicating with one another. So I'm going to say, maybe go affinity US South Central. So by naming that affinity group for South Central, when I create my hosted service, I can reuse that. So this is now going off and creating our storage account. So a storage account can have up to 100 terabyte of data within it. So that's quite a lot. If you want more, you can create more storage accounts, or you can lodge a special request. Over here, you can see here are those publicly addressable endpoints for my blobs, tables, and queues. We've also got something that's quite important, and that's a storage key. So storage keys are our way of protecting reads and writes to that information. And we'll get into that in a little while. So that's a storage account. What about our hosted service? So I'm just going to collapse these guys down a bit. I'm just going to hit new hosted service. So it's going to be GB demo 2. Demo 2. Going to go off, and I think I used Affinity US South Central. Now, how are we going to deploy something here? Well, we're going to have to create a package. Just going to jump back into this guy. Now, we were just running on the local compute emulator, right? So what we need to do first, before deploying to Windows Azure, is to specify where is our storage? How is our hosted service going to communicate and, store that information that we're providing it? So I'm just going to come and probably click out of this because I didn't copy it into my clipboard. Just going to copy this key. So I'm going to copy this key here. And I named the storage account Nick1. I'm going to come over and configure this guy. So this is my data connection string used by the web role and the worker role to read and write from our storage account. There's the key. Just hit OK. Going to do this one too. So we're configuring the web role first. It remembers your key for you. Going to go and configure the worker role as well. Okay. One more. Okay. So that's good to go. How do we publish? Well, you can publish in two ways. You can publish straight out of Visual Studio by connecting up to your hosted service. I've got a few created here earlier, which it's just loading up. Let's give it a second. There we go. I'm going over Wi-Fi here, so it's a little slower. And you can deploy to your proto staging slot. What I'm going to do, because we're creating a hosted service, is we're just going to create a package. So the package is what a package is your cloud project defines what your services and storage look like in Windows Azure. Now, when we go to, say, make a release up into the cloud rather than running on local, we need something to give Windows Azure such that it knows how to go and configure it. So all of our code, our assemblies compiled is dumped into this package here, and there's our configuration file there. The service def goes and resides in here. So I'm just going to copy this link. Come over, new hosted service. It's going to be quick here. Going to put this guy there, and we're going to utilize the package this way, this time. So we're just going to browse to that guy. Select the guestbook. So that's our package, which defines our web and worker role. And then we're just going to browse to the config file, which I'm just going to open it here so you can see. Has our connection strings to data, and you can see they're pulling that information which we just set in the config. That's it. Hit OK. So this is telling us that there's only one instance. So to meet the 95.95 SLA, you need at least 2 instances. So we can ignore that. Now that's going to go off and go and deal with finding the right amount of cores, extracting our web and worker role out of that package, configuring IIS, publishing it, making it publicly available. So that's it as far as that's concerned. Now, I created one here earlier, and what you can see is I've made 2 deployments, one to staging and one to production. Under that, we've got 2 roles here. We've got our web and worker roles. And if we do this, you can see that this guy's running there. Now, this production slot is publicly addressable here. So you can see it's at GB Demo 1. We've got a guest book account there. You can go and utilize that. If we come back here, we can also see staging slots are publicly addressable. We use a GUID such that people aren't going to easily be able to find that staging environment, because it is public, right? It's not going to be internal to your corporate network, and that's that. So if anyone wants to go and start pushing images in here, it's GB Demo 1 at cloudapp.net. We can check that later in the session. So that's it. If you want to go and then scale on demand, it's really quite easy. So I'm going to do that here. So recall how I showed you the file which has the instance count. So this is quite powerful. Let's say you've got a web role there and it's getting hammered by thousands or hundreds of thousands of users. You can just come along, change a simple configuration setting, and then that's okay. Let's talk about the worker role. Then it's going to go off and now spin up 2 more instances underneath this guy. So that's going to go and scale out for us. So that's quite powerful. So let's just jump back to the deck now, and we'll get into some phone stuff. So I hope that gives you a bit of an understanding about the portal deployment process and the 2 core concepts being compute and storage. So what about WinPhone 7 and Windows Azure? How can you leverage Windows Azure for your WinPhone 7 applications? We've just seen a web-based client, but quite literally a phone-based client is no different. It's a client connecting to some services in the cloud. So why phone and cloud? Well, the cloud levels the playing field. So you guys can be, say, Microsoft interns, or you may be a Microsoft employee. What it means is you have at your hand a whole pool of resources from which you can pull when you need them. So if you want to start small, being perhaps you've got a really great idea, you go out and build a WinPhone 7 application, you go out and you don't need 1,000 instances running up in the cloud, you just need 1. So the cloud enables you to pull from that larger pool of resources when you may start getting that sporadic traffic or just large demand for your services. It also provides us a way to reach across device platforms. So if you design your services correctly, you can not only be consuming them from Windows Phone, they can be consumed from a website, a Windows app, a WinPhone 7 application, an iOS app, or whatever client you'd like. So we'll look at some stuff around that later. So that's cloud now. Why Windows 7 and Windows Azure? So Windows Azure has built on top of it, or included within it, a lot of additional features which are of use. So first thing is Windows Azure is platform as a service. So what this means is you go off and you build your application and we run it. Now, as you've seen there, for me to go and scale something out, it's incredibly simple. You don't need to go and deal with, learning or figuring out how to deploy these things. You don't have to go and buy the hardware. You just go and say, I want 4 instances, I want 1,000 instances, here's my package, job done. We also do the OS patching for you. So if you've got, say, minimum 2 instances running in the cloud, what happens is they're split across upgrade domains. Now, what that means is when you need, say, critical hot fixes or patches, what will happen is within our data center, it will go off and go and apply them for you. And with the separation between upgrade domains, what that means is it's going to take down one instance, upgrade it, while the other one's still there serving your clients. And then once that's done, it comes back up, the other one goes down and comes out of the load balancer rotation. So it's quite powerful there as well. And I guess removes a lot of effort that you may have to do with going and managing that service yourself. Scalable compute, but also scalable storage. We'll see the storage scalability towards the end of the session. Utility billing. So you're only paying for what you use, and that makes it very easy for developers, such as even myself. I went off and started a startup, and I was able to do it at very low cost. So apart from that, on top of Windows Azure, we have a whole array of services that allow you to build sort of globally scalable applications, and also utilize some cool things like the access control service, which is, I guess, the access control service provides identity federation against existing social identity providers. So what that means is you can utilize ACS to outsource the authentication for your application to Facebook, Google, Live ID, and it's quite literally under a 60-minute process. There's a lab in the training kit that'll walk you through that. So it means you are then utilizing the ACS to do your authentication, and you can do that across these alternative identity providers. You don't have to deal with going and creating your own. Traffic Manager. So Traffic Manager provides load balancing across data centers for globally redundant systems. So this is more for, I guess, distributing your application globally for your hosted services. Whereas CDN, Content Delivery Network, allows you to push out your blob storage to 24 edge nodes around the world and allow that data to be very close to the user and thus reduce the latency of access. Caching service, so we also have a distributed in-memory cache available such that your scaled out instances, being your compute or your web or worker roles, can go and utilize that cache to perform lookups without having to hit a disk, which can be quite time consuming in the sense of, if you're building a scalable application. And lastly, common development tools. Same Visual Studio, same development languages, and emulators built right in. So key considerations building Windows 7 applications. You may be building a Windows 7 application and that may just run on your device. So if it's running locally on your device, you're limited in terms of the connected scenarios. You're not going to really have a story there. If you want to start building applications whereby you're utilizing some services to provide extra value to the application or communication between them, then compute allows you to provide, say, WCF services, websites and whatnot to go and allow these connected scenarios. Storage, are you going to go and store, for instance, your images or video that you collect locally on the device, or do you want to share them? Do we want to push them up into the cloud? Communications. So do we want to, say, for instance, utilize push notifications and have some form of business logic running up in the cloud that determines when the best time to notify a user of a change is? And identity. How do we authenticate users? So there are some key considerations there, and we'll go and look at each of these. So compute. So we've already talked about the concept of web and worker roles. What's the key difference? Well, a web role has full IAS. A worker role does not. A worker role is more, as I said, like like a DLL with a main, or it's like a Windows service. It sits there and runs. It's headless. You can go and host WCF services in there if you want, but a web role is more compelling for that. Both implement the role entry point, and we've already looked at the on-start, run, and on-stop overrides. So that's your compute storage. So what are our storage options? So in the demos you've seen thus far, we've only covered the tables, blobs, and queues. But we've also got another offering here, so SQL Azure. This provides a relational DB as a service in the cloud. So everything you know about SQL Server today, your knowledge transfers. Same concepts, stored procs, tables, foreign key constraints, primary keys. It's all there, just available in the cloud. It's highly available, and we manage it for you as a service. To provision one, it's done through the portal. It takes under a minute to click through and configure it. Windows Azure Tables. So these guys, they're providing scalable, available, and durable structured storage, where SQL Azure provides a relational model. This provides a model that's not relational. The way it's set up is you identifying an individual row is defined by a partition key and a row key. That, if you're a SQL guy, is similar to, say, a composite primary key. The partition key is utilized to group common data for scale out, which we do behind the scenes for you. And we also have in there a timestamp such that you get optimistic concurrency. What you don't get is the ability to perform queries that join between tables. It's non-relational, so just remember that. But what you do get here is massive scale out. So your storage account, recall, has 100 terabytes of capacity. So you could quite literally have 100 terabytes in one table within table storage if you liked. Whereas currently SQL Azure caps out at 50 gigabyte, but you can shard it. Windows Azure Blobs, so perfect for binary data, videos, images, XML, accessible using like a HTTP GET, and queues, persistent async messaging, perfectly used for communicating between a web and worker role to offload processing or long-running tasks. A message can be a maximum of 8 KB. We do have some metadata attached to that, which I believe brings the payload size of your messages down to 6.4 K. So you can pack that out with whatever you want. It may even be packed out with a link to blob storage, which has a whole heap of work for a worker role to go and do. So that's the way you go and exceed that threshold in terms of packing out a message to do more. Yep.
Could you give an example of where you would use SQL Azure versus Windows Azure Tables?
Yep. So the key thing, I guess, when I find I'm using it, it's what is, I guess, the use case scenarios for your application. If your user stories are very heavy in terms of your entity model needs to know about something from this entity, this one, which may be stored across separate tables. You may need to, say, perform an aggregation between those, or a join between those three, for instance, and then aggregate that data to, say, do a count or a sum or min, max, those sorts of operations. SQL Azure is best suited for that because it offloads that to the SQL Azure engine. Whereas with table storage, if you wanted to do a similar scenario to that, you're going to have to hit each of those tables separately and do it in memory. So there are tricks to the way you can design your tables to sort of optimize if you do have a few edge cases and you want something relational, and plus there's also the opportunity to do, for instance, a model which utilizes both.
Okay, but like, what is the primary target for a table?
Table storage?
Yeah, like, why would people use it?
Okay, so let's say, for instance, Twitter, millions, billions, I'm not sure how many users. Table storage, 100 terabytes of data, massively scalable. SQL Azure at the moment, you have 50 gig, and then you have to deal with sharding if you want to go across that. So out of the box, you've got quite a powerful tool there, straight off the bat. Okay, so that's storage. let's look at how we go and start accessing this information. So from a device. So key thing with devices, who uses Bing Maps at the moment, for instance, the Bing Maps control? Who embeds their Bing Maps key in their application? Right, so several of you. So what that means is that's easily compromisable. Someone can retrieve your Zap, go and pull out your key, and start doing whatever they want with it. So in that particular case, they're just going to be hitting the services using your key, and it'll get to a level where I don't know the specifics, but you don't want that to happen. So in this case with mobile, what we're looking at here is SQL Azure. How do we expose your data? So what we do is we stick a web role in between, and we expose it with something like a WCF service with Entity Framework 4.1 there. WCF data service, Entity Framework, and we go and create an OData service, all in the matter of about 5 minutes. Your key is then stored within the proxy hosted in Windows Azure. It's not on the device. Your device can then communicate to the web server. So in this case, we're going to store a record, goes straight into SQL Azure storage. So easy, but hides our key from being easily compromised. So next, what about blobs? So that was SQL. Now let's talk about Windows Azure storage, being blobs, tables, queues. With this blob here, what happens when we want to go and upload a blob? What's one method or pattern for access? Considering we want to hide those keys that I showed you within the portal. So in this one, we may take a picture on the phone, upload it to a web role. The web role then goes and stores that picture in blob storage. Later, we then come and pull that blob down to the device. Now, the key thing to understand here is to write to blob storage, you need a key. So your blobs can be publicly accessible, read-only, but writable has to be done utilizing a key. In this case, again, the proxy hides that key from compromise. This is the bad practice, worst case scenario. You can utilize the REST-based API to push your blob directly to blob storage, but you're going to need to embed that key in a header on the device. That's bad. People can get at it. Okay, what's a different approach? So we've seen that there was one direct, bad because we have the key on the device. We've seen there's one where we push the whole blob through a web role. Well, what's the problem with that? If we're pushing all our blobs, images, videos, through an intermediary web role, then your ingress on that web role is going to get very heavy. It's information that you don't necessarily want to go through that intermediary. So what we've got is the concept of a shared access signature. So this is like a time box token that's embedded in a query string that gives you write access for a period of time to blob storage. So in this case, our device requests from our service to say, hey, I want a shared access signature so I can write a file. That shared access signature may be sort of restricted to one small portion of blob storage. We get that, and then we can write directly to blob storage. And then, publicly readable, you can pull it down. So in this scenario, you can see what's happening is we're no longer pushing that blob all the way through this trunk. So in terms of any web server, there's going to be a certain amount of ingress it can handle in terms of its capacity. So we've dramatically reduced the amount of ingress that's going to be going through this web role just by getting a small token back, and we've offloaded that all to Windows Azure storage services. So what about tables? So whilst blobs can be publicly read-only, tables are never publicly read-only. You can't get at that information without an intermediary or providing the key to read. So while we've been looking at write, reading from tables needs to be done utilizing a key. So same concept again, and I think it's probably getting through to you guys by now. We're using a proxy, in this case to perform a write. If we were doing a read, it would just be the reverse direction. So, key concept. Do not store your secrets on the phone, otherwise people will get them. With a 100 terabyte storage account, you don't want someone getting access to your keys, because who knows what they will upload to that space, and who knows where they'll be serving that within the world. So, communications. Communications on a device, two methods, phone initiated, cloud initiated. So for instance, phone initiated, are we calling into our services? Cloud initiated, are we pushing a message through Microsoft push notification services? Okay, so phone initiated options, all HTTP based. We've got choices of frameworks. Are we going to use WCF, OData, a web request? How are we going to serialize that data to and from those services? Be mindful that, for instance, SOAP can be or is heavier than other alternatives like JSON or POX. So if you want to reduce, again, further what's being pushed and pulled in and out of your services, you can choose a different wire format. Cloud-initiated communication. So push notifications is a good sample. Perhaps a web or worker role that goes out and pushes messages to a device. Now, push notifications, if you were to go and build your own, then what you may have, if all the apps could run at once, is multiple things listening for notifications across all the apps that may be on the device. So the implementation of this on WinPhone, in my opinion, is quite smart because it's going to have one single connection on the phone for dealing with notifications, utilize the Microsoft Push Notification Service. It's bandwidth and battery friendly, but push notifications have no guarantee of delivery. But they are, in practice, very good. So we've got three kinds of push notifications. Who's used a push notification before? On WinPhone 7? Okay, cool. You'll see a demo soon. Raw. That provides you the ability to deliver a payload of whatever form to your running application. Toast. That's the little pop-up you receive on the top that you can click on to get into, that clicks you through into your app. Or tile, which is your tiles on your start screen, which can have a badge or tile change. Now, subscribing to push notifications. In your app code on the client, you request a channel URI from the Microsoft Push Notification Service. You submit that channel URI to your web role where it may put it into, say, storage, such that your business logic can go and address that particular device or group of devices later. And then when it decides to do that, we utilize a web role or worker role to go and write to that channel URI, which eventually returns it back to the device. So identity. So there's a few options here, phone. Go and create your own. That's going to require you to go off and create your own registration pages, storage in terms of backend or whatnot. It's a bit of a headache. You can use ASP.NET membership providers, which out of the box, same as in web, you can apply them to your services and utilize them from your phone. You could go and use a single identity provider like LiveID or Facebook, but those APIs do change, which means that there's extra effort for you when those changes occur to go and upgrade your code base that's interfacing with them. Or you can outsource your identity management to ACS, which means ACS is this magical bubble in the cloud that sits in between your application and those identity providers. If something changes in terms of the interface for those identity providers, well then it's Microsoft's responsibility to come and update those, and they've already got an established relationship whereby they'll be doing that before you even know that it's happened. So, I'm not an identity expert. I'd suggest that you come and look at this particular one, being WinPhone 7 developers. So authenticating users in WinPhone 7 via access control service. Now, this lab is under 60 minutes to implement. You configure identity providers, your LiveID, Facebook, Google. You set up a relying party, which is your application or services, and you configure rules to use when logging to the application. So I won't go much past that because it's best you look at this one in terms of identity. So that's a lot to go and digest. So what makes all of this easier? Windows Azure Toolkit for devices. So this is something that the guys on the team have put together. Wade, it's a shame he can't be here tonight because he's worked, I guess, very diligently on this. And what we've got is something that goes and provides those set of services that we all just talked about in a file new project way. So we've got one for Windows Phone 7. We've also got one for iOS. So those two, the WinPhone 7 and iOS, will create all the client components, and we'll see a demo shortly, to call into a Windows Azure hosted service, which you can go and deploy into the cloud. So it means that you have the reuse of that services from multiple devices. Android is coming soon. So that will, again, will be supported by the same service sitting in the cloud. One service, and once Android's delivered, that's 3 separate client applications that can utilize it. So the toolkits include native libraries for interacting with all of these, project templates, samples, documentation. So let's look at this. So here it is here. It's on Codeplex, WA Toolkit, WP7. Come down, there's a whole lot of documentation there. There's a couple videos you can watch. One here specifically on identity, which goes into using ACS. I recommend that one. It's only like maybe 11 or 12 minutes. And we'll do a similar demo to this one now. So all you have to do is download to get this. So let's jump straight into Visual Studio because we're starting to run low on time. So, File, I've gone off and installed this. Right? And what that does is when you install it, you get these 2 extra guys that you don't get in the Windows Azure Toolkit. So the first one here is a cloud application with a client and services all set up. The other one has an empty client application if you want to go and start writing something from scratch in terms of the client, utilizing those services on your own. So I'm just going to hit OK. I'm not going to save my changes to guestbook. Now, this screen here is saying, do we want to utilize a storage account in the cloud for our initial, templated, here's your solution. So you can go and change that the way we did when we did a deployment, easily through that UI config. Or if we want to just keep it local when we start doing our dev cycles before we're ready to deploy, we just say, yeah, let's use a local storage emulator. Now, push notifications. Do we want this set of services to support push notifications? Microsoft push notification service support, pre-checked. If you want to support Apple push notifications and have the code generated for that, it's just simply clicking that and going off and selecting the cert that Apple provides you when you sign up. So we're using local storage emulator and push notifications. Next question. Remember these key things that we talked about? Identity, compute, storage. So identity. Do we want to use ASP.NET membership as our default provider for the phone? Or do we want to use ACS? So I'm just going to go with ASP.NET, but I strongly encourage you to watch the very short video on that Codeplex page, WA Toolkit WP7, for the identity scenario, and you'll actually see how powerful that is. If you have any sort of, inklings around, not too sure which one to choose, if you click out here, it'll take you straight to the documentation and walk you through, the differences between them. Right, so straight off the bat, here you go, you're getting a phone app, you're getting a cloud project with a web role, and we're getting a website. If you look at the website, it's got a whole lot of services here and artifacts that are not just consumable by this sample client application, but they're also something that if you didn't want to use this whole thing, you could then go and pull those individual components and utilize them in your own apps. So I'd certainly say look at this from 2 perspectives. One, that we're providing all of this in a service that's ready to go, or if you just want bits of it, all the code's there. So here's a shared access signature service for blob storage, for instance. So I'm not going to dwell too much on this because we're running low on time. I'm just going to change this to emulator. I'd encourage you to read through the documentation here. It's got a few useful pointers. And let's spin this guy up. So again, building phone project, firing up, which should be familiar, the device emulator there. And it is spinning up my compute emulator in the background, and I'm just waiting on the website to pop up, which should be there any second. A little slow on battery at the moment. Here we go, it's coming. See the site popping there. So it will eventually pop up in the browser. So let's let him click into the app. Right, here we go, we're rocking. So we need to install this certificate into the local cert store on the device such that it can communicate and have a mutual trust with our services. So that's done there now. So Seems like my emulator's not having much fun here. Right. Sorry. So you know what, I'm just going to stop this guy. Seem to have emulators popping up all over the place. It's a bit bizarre. And an exception. Alright. Let's do this. What is going on? Well, if there's anyone from the Windows 7 team, that's a bug. Although I must admit I'm not updated to the Mango emulators. This is older. The toolkit does run with Mango bits. So let's do this again. And I do apologize again, but we still got a little bit of time here. Let's see if it's happier now with the VS close and open. So how are you finding it so far? Is it a lot of information to digest? Yeah. All right. The key thing to take away is it's very easy to do your Windows Azure development. You can see in, for what you're getting, for what you're putting in, you're getting a whole lot of value in terms of that scalability and services without very much investment at all. It's just a matter of being able to sort of click through. All right. This looks like it's good now on the emulator side. It's not going to pop up at anything there, so let's go again. Righto. This is probably... Right. Let's install this cert again because it's a new instance of the emulator. Right. Now, first thing, what does the user do? He registers. I'm hitting page up here so I can type from my keyboard. I'm going to pick a password, and that is my Microsoft password, so don't use it. Right, we're going to go off register. That's registered against our services, right? Now we can actually come in and log in. So I'm glad that this is all now working fine for you because this is going to be quite good. So, push notifications. Right. Enable them on the device. I'm registering with the Microsoft push notification service. I'm getting a channel. I'm providing that up to my service. And now if I refresh this page here, you can see that Nick is now listed as a user that we can send notifications to. So let's send a test raw message. So raw messages are delivered whilst the application is running. They won't be delivered if the application's not running. So straight out of the box there, you've got push notifications working and being delivered for you. Right? Easy. Let's log out here for a second. Okay, it's not liking that, but let's try and pin him anyhow. Seems like I'm losing my little toolbar there. Let's go back. I'm just going to pin this guy. So pin, come here. So we're going to send a toast that says test 2. Hopefully he will work if it doesn't still have that other instance running. Okay. Guys, I think unless they can edit out this part of the video, that I probably should stop here with the demo and perhaps show you a video after the session, unless you're keen on continuing watching. Let me just log out here. Yeah, see, something's quite bizarre there. It's staying logged in and I can't even back out of the application because my toolbar is hidden there. All right. I'm just going to continue with the rest of the presentation and I'll play you the video just demonstrating the rest of those services afterwards. I'm not too sure what's going on because it should be fine. I'm just not sure if I've got something funny going on with a few emulator processes or something in the background. Right, so do apologize about that. So scale. How do we scale out workloads? Well, in this case, we're saying, okay, we've got a phone. We did see the raw message delivered, but that was delivered through a website in the web role. We just sent a raw message. What you can do there, though, is what happens, say, if you have a lot of devices on your end or a lot of devices delivered to deliver that message to. Let's say you've got 10,000 notifications to make to a group of users in your application. How do you go about doing that? You can't really offload all that work from your web roles easily with scale. So what you do is you enqueue that message. So you say, user A wants to send a message to a huge group of people. I'm going to enqueue a message. I've got a worker role here that sits in between, picks up that message, then we'll iterate through that group of users, say in table storage, and notify the push notification service. That then sends out our raw message, in the instance that we demoed, to all of those users. So that's scaling out of your compute. But what about your data? Let's say you want to be accessing your image or whatnot from blob storage. Now, if you're sitting in your hosted service up in North America and you're a user down in Australia, what's going to happen is if you're trying to hit that service, your storage account, there's a very big latency between where that user is in the world to where the data is stored. So we've got a content delivery network. All those little black dots there are actually edge nodes in the CDN, which can cache that information. So let's look at the case whereby he requests that and it comes back. Big duration in between. What does the CDN do? Well, you request to the CDN. You say, I have a DNS name. I want that file. That file is not in the edge cache, so you do have that first initial latency going off and getting that image and bringing it back and caching it. Now, that returns it to the device. Now, let's say after that, every other subsequent user in Australia that wants to access that image, they're only going to have a very small round trip between those two. So this is quite a powerful concept for delivering your content, being your data. So I'll take questions at the end just because we're running low on time. So here's a little tracer going against direct blob storage. You can see down here, there's quite a few hops before the trace is complete. Now, if I go over here, this is from Australia, and my hosted service was in South Central US, I believe. Now, this is the CDN node. It does support, giving a CNAME to that, such that it's nice if you want your application to look nice with that. But you can see when it's requesting from the CDN, it's only a few hops away. So this is incredible in terms of making your app very responsive. So that's storage, but what about your services? So while storage can be pushed out to edge nodes, what happens with your web services that you're calling into to, say, write information about users? Well, take this example. If I've got it hosted here in the US, as I get further and further out from where the hosted service is, in this case by Europe, that looks like 200 milliseconds, that's going to result in a very big latency for that user to hit the hosted service. So what concept is there similar to a hosted service, to the CDN for a hosted service? Well, we've got Traffic Manager. So this allows you to deploy your application in the data centers across the world. There's 6 data centers, 2 in US, 2 in Europe, and 2 in Asia. Now, when a user makes a request, what happens is it'll go through a DNS to whichever hosted service has the lowest latency. So you set up a policy there which defines how you want that routing to occur. It could be round robin if you want something like that for spreading load across the world, but that will have latency. Or you could go for a performance-based approach, and that's just ticking a box. And then there's another third option, which is failover. But that just gives you the idea there that, hey, you can then deploy this as a global app, and your users can be routed to the best performance-based in terms of latency data center that's close to them. And that is, I believe, it. Thank you. So what would you guys like to do? Would you like questions, or do you want to see a video of the Win Phone bit? What would you prefer? Video? Video? Yep, cool. All right. So here we go. And perhaps Wade sabotaged my machine, so I would play a video of him and he'd get some airtime. So we might need some audio here.
Today I wanted to give you an update on our
right,
Windows.
and I'm just
Many of
gonna-
you are like me. You probably, unless
just
you
gonna
install
pull
the
through.
certificate on the device. So you can
Right. Let me make this big.
see, for development purposes, we install a link here that if you select it, will take you to the certificate. You can select this and choose to install that certificate on your device. And now we can do secure communications to this SSL endpoint without having to worry about the fact that it's a self-signed cert and not trusted. Now, the very first thing you want to do is click register, and we'll create a new username. If you're using the emulator and you want to use your keyboard, go ahead and click
I'm
register.
just pulling forward a bit here for
See,
you.
now I'm going to put this login and password in, and you'll note that we have the ability to remember me. And what happens is if you choose remember me, once the user goes to sign in, we're going to get back a token that we'll use to embed in all the request headers from here on out. If you select remember me, it's going to store that request header token locally on the device so that it can remember who you are, so that you don't have to log in the next time the application launches. So we'll go ahead and hit login. And we've logged into our application. Now, on the very first tab here, you'll end up seeing that we have support for notifications. And what I want to demonstrate is if I come here back to the website to Microsoft Push Notifications, you'll see that I don't have any channels registered with our application. So let's go ahead and register this channel. In a moment, this will connect, and you'll see here that it has connected. So if I refresh this page, we'll see our demo user. And so let's start sending a message right away. Let's send a raw message. So we'll say test raw 1. And over here on the right, we'll click this link, send raw. It's received a device 1 of 1 success, and you'll see here that our application was successfully received our test message. And we could even go ahead and send another message as well. So let's say test raw 2, and there's our message. So very, very easily, without having to write any code, literally just hitting F5, we already have it set up so that we have push notification service support for our application, even in the application. Now let's test the toast and tile as well. So I'm going to go back to the phone device, and in order to test this well, I'm going to pin this to our phone, so you can now see that I've pinned it. Let's go ahead and now send a tile message. So we'll say test tile 1, so we'll send that tile. And you can see here that we've received an update, and we've numerically updated our tile, so it shows 1. Let's go ahead and send another one as well. So send tile 2, and it's updated to 2. So that's great. And then lastly, let's send a toast. Send toast 1. And you'll see here that we received test toast 1. And what's more is if we select it, the application is set up such that it will also pull a copy of all the push messages sent to toast and to tile and display them in the application the first time we open. Now, this isn't done through any sort of linking with the notifications on the phone, but instead when the application opens, it's going to check to see if there were any recent messages that were sent to the phone device that we haven't displayed in the application. So that's a nice capability that's provided right out of the box. Now let's move through the application and take a look at some of the other capabilities. Here you'll see that we have the ability to use the Windows Azure library for storage to display and interact with tables. In fact, you can see here's some tables that already exist that my user has access to. And here I can create a new table. I can even delete this table if I want to. But what's more is not only do we have the ability to create these resources, but we have the ability to define authorization on top of them. So for instance, let me create a new table. And now on the website, let's come over here to tables. And you can see here's this new table that I've created. And my demo user has access to that table. Now watch, I'm going to remove access to demo user. I'm going to come back here and try to delete that table. And you'll see here that it says you have no permission to use this table. So we've shown the fact that because of the fact that we're proxying the access through a set of services running in Windows Azure, we have the ability to add an additional layer authorization on top of our tables. So let me add this back and delete this table, and you can see now we've been able to delete it. So that's pretty neat. Also, in addition to interacting with tables on a high level, we also have the ability to interact with the data within the table. So for instance, here I'm going to go ahead and create a new row. This is just a sample table that we have created, and the model is defined on the phone. And I'm going to say, Wade, it's an evangelist, and then the number really doesn't mean anything. It's just an example of the fact that you can use numeric data as well. We'll go ahead and save that. You'll see here's that record. I can select it again. I could update it if I want to, and I can also delete it. Now, the main thing that we're demonstrating here, the fact is that we're able to do these type of operations from the phone device. So you could modify and extend this to your own needs. Now, we also have the ability to look at blobs and to interact with blobs. So I can say list blobs. You can see there's no blobs found. So let's go ahead and create a blob record. And we're going to do that by using the phone device. Now, what I did is I clicked the button to take a picture. Now, on the emulator, you can't take particularly interesting pictures, but it did create this picture. You can see it's got a black box up in the upper part of the picture. I'm going to go ahead and upload it. So it's uploaded that image. In fact, now once I click list blocks, now you'll see here it is. It shows a preview of it, and we could even open it up and take a look at it in the browser. So that's kind of cool. Now, in addition to blobs, we also have support for queues. And so you can see here's a queue. I could try to list queues additionally, and I can also create queues. So here's a new queue that I just created. And if I select it, what I can do is start to queue some information in it. And so I'm going to say Q1, say Q2, Q3, and Q4. And so we've just queued up four discrete pieces of information, and I also can call a dequeue on it. So here's, I'm dequeuing 1, 2, 3, and 4. And so let's say if I want to dequeue 5 or queue up a record 5, just like we had support for authorizations on top of tables, I can come here and I could now try to dequeue, see that I have no permission to do so, give the permission back, do the dequeue, and there I can get it. So that's a quick demonstration of how to use the Windows Azure Toolkit for Windows Phone 7 and how to use some of the services built into the toolkit to quickly get started with things such as storage and blobs, tables, and queues, as well as push notifications through the Microsoft Push Notification Service. Thanks, and I hope this has been helpful.
Hello, thanks for sabotaging my computer. No. So the key thing to take away from that demonstration is, whilst it's a very generic demonstration, that device is actually utilizing services in the cloud. In this case, it's running in the compute emulator, but you can design your application to utilize those in the client app. Now, whilst that's generic, it's showing you a few, I guess, fundamental concepts that you could go and apply to application scenarios. So let's say it's a messaging-based application, and you want to start a chat, for instance, with perhaps another user on another device. You could have utilized that queuing mechanism in the cloud to enqueue, some text you've typed through to him, and then the other client application is dequeuing from that same queue. So it's a good example of generically how to deal with that: tables, queues, blobs, and I guess you could say you can then take that and use it in your own app. So thank you, that was good. Okay, so should we wrap up and do some questions offline, or? Sure. Yep. Okay. Cool. Okay, guys.
Thanks, Nick.
Thanks.